Today we're talking about exponential growth and decay. We're going to graph exponential growth functions and exponential decay functions. So first of all, we want to talk about what an exponential function is. And an exponential function is a function where the x variable is in the exponent. So a function where the base is a constant and the x is in the exponent. Okay. So the base b has to be a constant, and this is the base right here. The graph of the exponential function has an asymptote, which is the line that the graph of the function approaches but does not cross. So right there, the asymptote. For this function over here where we have y equals 2 to the x, the asymptote is y equals 0, and that is this line right here. So although it looks like this graph does touch the x-axis, it actually does not touch there. There keeps a space between there, and although it'll keep shrinking and it closer and closer to 0, it will never touch this axis here. So in this case, we're talking about the asymptote. And that is always going to be an equation for this one, where it's going to be y is equal to some a value. So it's also a line that the graph approaches. But doesn't cross. So we can get a little bit more specific about exponential functions, and we can talk about exponential growth. So here we have exponential growth. And when we're thinking about growth, the b value or the base has to be greater than 1. So it has to be a number bigger than 1. So the graph rises as we read it from left to right, passing through the points 0, 1, and 1b. So the b means right here, whatever the base is, if we raise the base to the first power, it's going to cross through that point. So that will be our exponential growth. As we read it from left to right, we see that it increases, and as we go further to the right, it increases faster and faster. The domain for this, domain is all real numbers, or in this case, we're talking about the x values. Every single x value as we go from left to right is accounted for. The range, on the other hand, there are no y values that are negative here. All the y values are positive. In this case, all the range is any y value that is greater than 0. Next one we can look at is exponential decay. And when we have exponential decay, that is when the b value has to be between 0 and 1. So that's our b value there. Has to be between 0 and 1. This goes through the point 0, 1, and still goes through the point 1b as well. We still read the graph from left to right, but in this case, as we go from left to right, this function is going to decrease. The domain is the same, all real numbers, and the range is the same, all numbers greater than 0. So that means greater than 0 means that it's going to get very close to 0 here, but it will never cross the 0. So numbers that could be between 0 and 1 are going to be fractions or decimals. If we see a fraction or a decimal, then we know that we're going to be thinking about exponential decay, and we know that we're going to start high and work our way down. So if we have a comparison between exponential decay, this over here is exponential decay, and this is the graph that is going to start very high, and it's going to work its way and get lower and lower and lower as we go through. We're going to get closer to 0, but we're never going to cross it. Exponential growth, that is going to be a graph that's going to start very close to 0, and then it's going to go continue to rise, and it's going to increase faster and faster as we go further to the right. So growth happens where y equals a to the bx when a is greater than 0 and b is greater than 1. Decay happens. Basically, it's the same equation. The only thing that changes is the b value. Everything else is the same. The only thing that changes for decay is this has to be a decimal, so between 0 and 1, or it has to be a fraction or a decimal.